All right, last page here. Okay, so I like finding the vertex first. Take the opposite. So vertex done. Domain. I'm not very good at finding the domain and range until I actually graph it. So here's my parent. And then the child will be -4, -1. And since it's let me do the transformation. So horizontal translation, 4 units left. Vertical translation, 1 unit down. Reflection over the x-axis. And then vertical compression by a factor of 2/3. Okay, so transformations are done. So that means I go left 4, down 1. And then I'm going to reflect it over the x-axis. So this is the x-axis. So what I'm doing is I'm folding it. So instead of it going up, it's going to go down. But then I have to show it's a vertical compression. So it's getting squashed. It's getting squished. So it's just not looking as curvy as that one. Okay? So now that I do that, it's a million times easier for me to find the domain. X, going to the right, is greater than or equal to -4. Bracket, -4, positive infinity, parenthesis, range. Y, because it's on the negatives, it's going towards the negatives. Y is less than or equal to -1. That means I'm going negative infinity to -1 bracket. Smallest to biggest. Ooh, that didn't sound good. Domain range, done. Additional point. So I can pick 0, because 0 plus 4 is 4. The square root of 4 is 2, but now I'm crazy because now I'm going -2/3 times 2. But I can do that because I'm good at it. So I get -4/3 minus 1. -4/3 is -1 1/3. So -1 1/3 minus 1 is -2 1/3. Now some of you went, what? Okay. See how the 3's on the bottom? I'm going to show you a different point. I would try to make this a 3. Which really means I'm trying to find the square root of 9, which means if I made the x 5, it'd be a million times easier for me. So 5 plus 4 is 9. The square root of 9 is 3. 3 on top, 3 on bottom, gone. And then -2/3 minus 1 is, I'm sorry, it's not 2/3, I'm sorry, it's -2. -2 minus 1 is -3. Let me do another one. Let's say I decide to pick -3 because I like to torture myself. -3 plus 4 is 1. The square root of 1 is 1. Times -2/3 is -2/3. Minus 1 is -1 2/3. Okay. You could either write it as -5/3, whatever you want. But if you give me a decimal answer, you obviously use the calculator. You got to show me that you didn't use the calculator. All right, let's get into the inverse ones. Find the inverse. First thing, switch the x and the y. We have learned that when you have a y in the denominator, you multiply it, or you have anything in the denominator, I should say. Remember how we have 2 y's, but the way to turn it into 1 y is to move it over and then factor it. So if I take it out, now magically 2 y's turn into 1 y. Now this whole thing is being multiplied, so the opposite is divide. So then it becomes, g of inverse. See how that's g of x? So I want to be careful. Of x equals 3 over x minus 1. Okay. All right, find the inverse of this one. Switch the x and the y. So when I solve, I always add first. Divide by -2. Now some of you go, Miss Rifkin doesn't like a negative in the denominator. Whatever. We're not finished. We're solving. So if you want to deal with it and put it on top, great. If you don't, great. So now what I'm going to do is I'm going to square both sides. This side is a lot easier. Okay? I box this top out and get x squared plus 2x plus 1. And then I square this over 4. The problem is you have to know that's ugly. So this is an imaginary 1. So this is really 1/4 x squared. 2 over 4 is 1/2 x plus 1/4 equals y over 9. Now I will say some of you here, you might have changed this to -1/2 x minus 1/2 and then squared it. Great, you should get this. Okay. I just think it's easier to not do that because I don't want to square a fraction. Now I subtract 9 and I get f inverse of x equals 1/4 x squared plus 1/2 x, you can, I am not going to be okay with you writing negative 8 3/4. That is super ugly. So please use the fancy calculator, or know that 8 times 4 is 32, plus 3 is 35 over 4. Or negative 8 3/4. I mean, I'm glad that you know that. It just looks pretty ugly. All right. Find the inverse of this one. Hopefully it doesn't take up that much space. I think it will. Switch the x and the y. Is that the fifth root? Subtract 6. Divide by 3. Now, since it's to the fifth root, I'm going to take it to the fifth power. Now that's really dumb. I'm not going to make you do Pascal and multiply it all out like you are in your project, but I'm okay with you leaving it like this. So you're going to go x minus 6 to the fifth power, and then you're going to figure out what 3 to the fifth is. I think it's 243, but I'm not trusting myself. Ooh, okay. So it's over 243, but that's ugly too. So you rewrite it as 1 over 243 parenthesis x minus 6 to the fifth power, all equals x minus 1. Oops, wait a minute, something happened here. I got too many x's. Sorry, something you noticed probably. Okay, goal is to get y by itself, so plus 1 plus 1. So my answer would be f inverse of x equals 1 over 243 x minus 6 to the fifth plus 1. Now you give me that, great. You have no life and you want to box that out and put it in standard form and get it correctly, I'll give you bonus. Okay. All right, they want you to find the inverse of this. X equals 10 minus 5/3 y. Some of you might subtract 10 first. Then you would multiply by 3. 3x minus 30 equals negative 5y. And you would divide by negative 5. F inverse of x equals negative 3/5 x plus 6. Okay, that's pretty, I know. They want at least 3 points, so x, f of x, 0. So I'll plug in 0 to the original dude. If I plug in 0, anything times 0 is 0. That's 10. Which means if I was doing the inverse one, I'll do these on a separate paper. X, f, inverse of x. I always do that. The first point would be 10, 0. And you know what I could do? Is I could pick whatever one I want. I can just do the opposite. So now I'm going to pick 3. Why am I going to pick 3? Because there's a 3 on top and a 3 on bottom. When I do that, they cancel. Then I'm left with 5 and 10 minus 5. So wait, I picked 3. That cancels. 10 minus 5 is 5. Now I flip it. 5, 3. Now I notice if I go in increments, watch this. Plus 3, 6. Minus 5, 0. Which means now let's flip it. So I did at least 3 points. And then graphing them. Alright, this looks like a lot of fun space. So if I'm going to graph this, I actually feel a little bit uncomfortable. I don't like that this is first. So I'm going to rewrite this as negative 5/3 x plus 10. So I'm going to fake it. Up 10, down 5, right 3. F of x. Do my reflection line, 0, 0, 1, 1, 2, 2, 3, 3, dash, dash, dash. This, I could also plot the points, I realized. So I could go 10, 0, 5, 3, 0, 6. Wait, this is way too fake. Whatever. And f inverse of x. Okay? I think we're good. All right, let me do these last two. Well, I can do this one over here. All right, looks like we got a lot of x's happening. So they're asking us to add all these and then divide it by that. For me, I don't even want to look at the bottom until I can handle the top. So this turns into x to the negative 1. And now this, I'm going to come over here And I'm going to show that I can add fractions without a calculator. L's least common denominator is 10 times 5 times 5, 5 times 2 times 2, 2. 5 plus 2 is 7/10. Now it's a little easier. Oh, that one ended up working out. Same thing on top, same thing on bottom. Bye. So now all I'm left with is x to the negative 1. But I can't have an x that's negative, so if I move it to the bottom, it turns positive, but it's rational. X cannot equal 0. Okay, last one. I feel like a lot of you can get this one, but it is bonus, so no big deal. Okay, x to the 11th. All right, so I'm going to do my piles. So if I see 512 and I see to the 7th root, I'm thinking there's a 2 happening. Let's see. 1, 2, 3, 4, 5, 6, 7. Let's start with 7, okay? Oh, no, that's not enough. So then times 2, 8, times 2, 9. So I got 9 2s. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then my x is 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. Okay? Let me zoom out a little bit. Therefore, I'm left with 2 on top, 7th root of 2 times 2, which is 4. Then in the bottom, I'm left with x and 4 of these x's. Okay? Now, the top's fine. The bottom's my issue. I need to have a pile of 7, but I only have a pile of 4, so I need 3 more to get me another pile. And now I'll be x to the 8th in the denominator. But what I do to the bottom, I got to do to the top. So now it becomes 2 7th root of 4x cubed. It's an odd root. No plus or minus. Okay? If you get those last two, great. If you don't, great.